on behalf of the university and on my own behalf to this one-day national webinar on a very important subject, solar responsive architecture. The webinar has been organized by Department of Architecture and Planning of Jagannath University, Jaipur. So I congratulate the organizing committee, Mr. Himanshu, Praveen, Jangit, and other faculty members for taking this initiative to organize this webinar, which was scheduled much earlier, but due to certain examination schedule and other things, it could not be organized at that time. So it is a great initiative, and in an academic institution, the departments, the faculty members, so they are always expected to organize such academic activities which are of higher level. Normally, we teach at the department level in the classrooms, but when we organize this type of activity, so it gives opportunity to everyone, to the students and to the faculty, to reflect upon the emerging areas in the subject which are important, which are relevant. So that helps to broaden the vision of the people, understanding of the people about the subject. So it is a higher level activity, academic activity, and for that, our department people, they deserve appreciation, and I congratulate them. Now, friends, the subject which has been taken for discussion, that is solar responsive architecture. In itself, it is of great importance. It has great relevance. So every person who is connected with the field of architecture need to have proper understanding that what does it mean when we say climate responsive architecture or we say solar responsive architecture. Then what does it convey? That it conveys that the solar path, solar position, the solar energy, so that need to be taken care of while designing architecture, while performing architectural jobs. Now, in the previous university, there was one dean of architecture. He used to say this thing, that architecture professionals are next to God. So one day I asked him that, Dr. Saab, you are saying that architecture people are next to God. What does it mean? You are according a very high status that next to God means something. So then he tried to explain that God has created this world, that God has created this nature, and next to God, how to live along with the nature, that is the role of the architectures. So it is the architecture is the most creative activity, that when we find that we have to, for a very, you can say, better life, it adds to art, it adds to beauty to our life. So when there are good architectural designs, and these are in accordance with the nature. In the present times also we find that if this corona is affecting whole of the world, now somewhere, it means that somewhere we have deviated from the nature. So we are not able to live with the nature, with the design of the nature. So in the present times, it almost now again becomes very relevant to understand that in the present scenario, what type of role architecture people can play. So that if there are, because architecture role is to create physical environment in which people can live. Now that environment must be congenial. That environment must be in accordance with the nature. So that is the issue. The another important point is, which comes to my mind, that we all understand that we in the present world are living in an era which is technology driven. There is a high use role of technology in our lives in the present times. Everything is technology driven, we find that. And experts say that in the present times, the most important, there are 5 most important technologies which need to be handled properly so that growth takes place or sustainable growth can take place in the world. So those 5 technologies which are going to rule this world in the present scenario, that include, number 1, we all understand, one is digital technology. That IT revolution has taken place, and there are a lot of advancements in the field of information technology, internet, digital technology, and everything, every aspect of the world, every economic activity in the world, even social activities, so now are affected, influenced by information technology. So that is one prominent technology. The second prominent technology is, that is technology for energy generation. Energy is the basic requirement of every individual for human life. Without energy, nothing can happen. Life cannot be possible now. The stage has come. And there are different sources of energy. There is a solar is one important source. There is a wind energy source. There is a hydroelectric, thermal, and there are many other sources. Out of these sources, solar or the sun energy, which can be generated from the sun, so that is one of the prominent sources. And at present, till now, not much source of solar energy has been exploited, has been explored. Now, as per data also, it is further said that 50% of the energy which is available in the world, that is consumed in buildings. That is a data of US. That in US, 50% of the energy consumption, so that is in the buildings. And that excessive use of energy, so that also creates certain environmental issues. So energy which is to be used, the energy source from where the energy is to be created, so that should be environment friendly. So that is another very important point. So second, energy is the technology. The third technology in the world which is prominent in the present times, that is technology for environment protection. Environment is becoming a very serious issue. Environment is becoming an issue of concern for whole of the world. And it is said that human life may not be possible on this earth if we continued with the same pace for the exploitation of the natural resources. So environment protection, technology for environment protection, now it is a global concern. That is a third type of technology which is going to be important or driving the whole of the world economy in the days to come. Fourth technology is biotechnology, that genetically modified products. So world is now, the trend is towards that. So, and the fifth technology, which covers all other areas, that is technology for human resource development. Now, experts say that these are the 5 technologies on which focus is required to be given in the world, so that there can be a sustainable development, so that there can be, the human life can remain possible on this earth. So it is in that context that we can see that when we discuss these things in the light of the architecture, the discipline of architecture, that solar responsive architecture is a very important subject. That designing of buildings in such a way that solar path, solar position, the topography, and the environmental conditions, the climate, all these things are taken into consideration while buildings are designed. Now, trend is there towards designing building where solar energy can be used as a source of energy generation. At least the energy requirements of the buildings are met through that source. So that is in need of the time. So in that context, so we have with us experts. So I welcome Abhishek Sharma ji, who is a keynote speaker. He will be sharing with us his expert views on the subject. And on behalf of the university, I extend welcome to Abhishek Sharma ji and our own faculty members, Abhishek Verma, Aditi Kapoor, and Aman Nirala, and Praveen Jangat. And in addition to that, our students also, they are going to make the presentations. That they are Mr. Rishabh, Nitika, and Abbas Mathur. So all these, they are going to make presentations. And our coordinator Himanshu also deserves appreciation for taking all this initiative. Now, with these words, because I'm not a student of architecture, so I welcome all of you and will like to listen to the expert views of the experts on the subject, which is very important, which concerns each and every person, every one of us, that how solar responsive architecture, so that can help to have a better life and better energy source on this earth. So thank you very much.
Thank you so much, sir. Thank you so much for inviting me and giving me this opportunity here on this platform, and totally to JNU to call me. First of all, I must say that it will be an exaggeration if I say that I'm an expert, but yes, I have been dealing with architecture, experiencing architecture, teaching architecture to a certain extent, also designing architecture uh, in different climatic zones. And therefore, I think after 25 years of being into this field, I can definitely share what I think of not only climate responsive architecture, but also what kind of trend we are witnessing. And as rightly said by Sir, that we need to live with environment. We need to live sustainably with environment. And I can hope that my presentation will open up a mind towards making better choices. I think that will be the main aim of my presentation. Um, Let me know if my screen is visible. Is it visible, sir? Should I continue?
Yes, sir, is visible.
All right. So basically, I say I open at the close, and I say this. I don't know if you have watched Harry Potter movie, uh, but there's a famous line there at the stone. It's engraved there, and at the very crucial moment in the plot, the message comes when Harry Potter is, looking for the treasure, and it means basically it's only when the end arrives, we open up to the better future. So with that, I think it's a critical times, not only because of pandemic, but also I think, as previously sir said, that environment, the world, the universe is telling us that we have taken more than what we deserve. And I think that is the basic principle behind living sustainably, is that we must take minimally, and we must be able to give back whatever we have taken. And optimum use of resources is what we should really strive for. And this is definitely the close, because resources are very, reserved, very limited. Our habits, unfortunately, have industrialized. Our wrong habits have actually multiplied, and we are causing immense danger to environment, and especially through our built environment. I will not use the word architecture, but because everybody is involved in creating built environments today, including the clients, the builders, the planned and unplanned growth, political wills. I will not get into that today, but yes, the entire built environment, this industry is responsible in a way. We are forgetting how we can take things minimally, and how we are abusing environment. So maybe we can, you know, through this little talk, through this webinar series, we can refresh our mind, remind ourselves how we used to live sustainably, and maybe we can make use of it today. Sun, I think I don't have to like tell you that sun is the epicenter of our solar system, the planet Earth, its rotation, its revolution, our life, our energy. You cannot imagine life without sun. So and yet we prefer it to, stay away, especially in tropic climate, especially in hot climatic zones. We want shade, we want refuge from the sun. And therefore, since, you know we started constructing, especially in tropical zones and in Indian subcontinent, intuitive wisdom guided us to tame the sun away from our built environment, to create shade, to bring shade, to ensure shade in our indoor built environment. But, what happens is, and this is not to offend anyone, but as chaotic as the screen seems now, this is what is going on. And especially in last 10-15 years, I see a lot of thrust towards relying on, computer software, and relying very less on the understanding of what the theory itself is. So what you see are these typical diagrams representing, common understanding of both students and professionals alike. Please, I'm sorry, forgive me if I am offending anyone. So in the name of solar chart and sun path, I see these smileys, every time I get an opportunity to see or review the work. I see some new kind of diagrams which are evolving every day and as every year passes by. So we see a lot of them. We see these arrows, we see these smileys, and even these kind of diagrams. And that's when my sort of heart sinks, because at that very moment, I know somehow that the person who is depicting it doesn't know what he's doing. And again, not to offend anyone, but what we see is the result, even in practice. And just to make a point here, if I'm sure you're aware of this building, I will not take the name, especially people from Jaipur. So this is the street, this is the Google map direction. So the entire theory is against what has been implemented. The glass facade faces west. The longer side of the building block faces west. And I still find it, funny that the Google is kind to this development, because when I was looking for this shot, it gave us the morning shot where you see the promenade in shade. But in reality, during the business hours, during the working hours, and throughout the day, this development, which is fully glazed, is exposed to the west, to the sun throughout the day in city like Jaipur. And I'm sure you understand when I say Jaipur, we are talking about hot. I mean, it's a composite climate, but predominantly hot and dry. So my question is that, when Praveen ji actually gave me this word, that contemporary, I was wondering what is new about it? What is new about the theory? Has the theory changed? So what is contemporary, in my opinion, is the poor understanding and somehow misleading practices and manifestations in ground realities. It is of a concern because when such manifestations are realized on the site, students come to us, the future generation comes to us and tell us that, look, that was created, that is already there. So why should we spend time understanding the theory, and why should we spend time doing those calculations? Well, it's all easily done through software, so why should we even understand about it? So the average understanding or comprehension of the entire sun path, solar path, sustainable and energy conservation architecture is limited to these fancy diagrams, which actually have no utilitarian meaning. And it leads to, I think, over the course of time, practices and such implementations of such buildings. And I already have apologized if I'm offending anyone. But I mean, the situation is not so bad. I mean, when you do look through Google Images, you do see that there are certain corners on planet Earth where you see the work, the kind of work which reflects that calculation has happened. That reflects that the understanding of selection of materials, orientation, the very understanding of what needs to be shaded is happening. And that is comforting. That is definitely comforting. Now, in this chaos where everybody, including me, can be saying things, and especially for future generation, the students who are enrolled in architecture right now, it's important to know what is the right way. What is, there is not a single right way, but then there has to be some direction so that they can, take and arrive at the solutions which are right. Another, quick recourse that we keep, hearing about most of the time is that let's just go back into the past. Let's go vernacular. Let's look into the traditional. And we are trying to research on it, and we are trying to find out some formulas. I don't know. Uh, and yet the debate remains that whether it was intuitive or through people, was it just the uh, intuitive blend with the craftsman skill, or was there some hidden shastra? But definitely, one thing is there in all these vernacular examples, we see that the human being had the wisdom to, shade the built environment, to keep their, indoors cooler during the day. And I think it's not difficult to understand that, because as I just said, that the entire solar system has sun as the epicenter. And throughout our life cycle, we can easily connect with the periodical path of sun, annual annual path of the sun, the daily path of the sun. So it's implementation in while creating built environment does not have to be only a gambit of research scholars or science or technically savvy people. And I want to remind today there was something in between. Of course, there's one extreme path that you can go back to traditions, ancient past, uh, or you can do the blunders that we are doing today, because there's a lot of chaos and confusion. But then there was a timeline, there's a period in the history of, development of built environment, especially in mid 20th century, which I think we are forgetting. We are forgetting that lane, that lot of work had was done, was experimented, the story of the forgotten. And especially I'm saying this because I firmly believe when practice was manifested in theory, or rather both were complementing each other. I can say this because I was sort of lucky to be, you know, uh, from a city which entirely got, planned from scratch. And only by experiencing those buildings, using those buildings, my father actually was fortunate to have a government accommodation, which later I found that was designed by Pierre Gendre. So all these kind of experiences made me experience the buildings in my hometown. Of course, I moved to Delhi, Dubai, different cities in India, now Jaipur, of course. And the thing that I want to share today is that there are certain buildings which definitely are climate responsive. That means the designers have definitely thought about solar path, sun direction in mind. And then there are many, many buildings which are turning blind eye to the whole thing. Now, one such example, I'm sure many of you know about it. The first, the concrete building of India, Golkund Ashram in Pondicherry. It's from the Aurobindo's ashram. It's the international guest house. Now, this building was designed in 1938, and it took like 4 years to construct. Its architect, George Nakashima, he was a graduate from MIT. Uh, Now, the reason why I'm sharing this is that nothing is new. The theory is not new. What is missing is its implementation. If you look at it, to bring the point, this is the snapshot. I hope you can see my cursor. This is a snapshot, the north sign here, and this is how the block is oriented on site. A linear block with longer sides facing north and south. East and west sides are the narrow edges of the block. Orientation, basic rule for tropical orientation. Applied. And let's look at what is happening otherwise. Building is concrete. Yes, we can crib about concrete being a bad material, But in warm and humid climate of Pondicherry, we see a treatment of roof by these shells or walls with, perforated openings which allow the breeze to pass so that, you can allow for convection cooling of the roof. And you have a double roof which gives shade to the top ceiling. Then you have this north and south facade with movable louvers. Mind you, there is no glass, but we have movable louvers. Even till date, it is said, and it's been confirmed again. Yesterday, I called someone to know they don't use fan. They don't even use fan in this guest house. I happened to visit this building in year 2000, and nothing much has changed. How is this possible? Warm and humid climate, concrete building, no glass but movable shutters. And they interlocked to avoid, rain splashes inside. And it is working. It was the wisdom was already implemented. The theoretical calculations that you perhaps study in climatology, good perfect example of how it can be implemented and we can have comfortable conditions within the building. Then there's then you get tempted to even go to, I mean, my stay in Jaipur is quite recent. And when you look at the walls and you look at the kind of development that is happening or that happened, way back in 1726 and 1730 with Vidyadhar Bhattacharya, look at the orientation of all the, I mean, this was the conglomerate here where my arrow is moving. It's for the local people, for the merchants and the workers. And this is the palatial development in the center, in the central block of Pink City, Jaipur. Look at the proportions. It's the courtyards are larger in size. I'm sure the designer wanted to give the very best to the patron king, and the large volume of the courtyard allows for more air to offer more convective cooling, and of course orientations for shade. So again, if you can look at the north sign, especially the students, and look at the orientation, the the red sign, the long side, east west, shorter necks, long side, yes, the long, it's so longer sides facing north and south, and east and west have narrow blocks. And of course, when you have a courtyard uh, sort of development, you have a orthogonal, uh, this disposition of masses, but then you play the trick with managing the openings that are facing east and west. And that's why you see Havanel facing east with marvelous work of sunshade, jali, and apertures to have wind. I will not get into detail here much because I'm sure there are many who know better than this. But what I'm trying to bring the point here is that orientation was definitely the key. The shopping streets, the major shopping streets, again, are oriented in reference to the cardinal directions. Very close to where I live, and Shimla again, 1822 to 1888, it developed more organically, unlike we think that it was a planned development. It was discovered, it was the territory was exchanged, but from the entire territory, they picked on the site, which was again, if you see, that permits the longer sides of the building blocks facing north and south, and especially The initial development was facing south, and even if you happen to visit Shimla, anybody of you, and you walk on the ridge, which is marked here in red, you will see the building blocks which are arranged along the contour, and their longer side is facing, giving them access to south sun. Again, the wisdom is talking about orientation. And another important thing that I want you to keep in mind is that we have been in Pondicherry during this presentation, then to Jaipur, and now Shimla, three different climatic zones. But the thumb rule that in tropics, the orientation, cardinal orientation, longer block, uh, placed in such a way that you have a longer face facing north and south and shorter face east and west. There's a consistency over, I would say, 200 years and in different locations. Uh, Further ahead, I mean, the biggest, independent Indian experiment, the capital city of Chandigarh, somehow the wisdom still continues. If you look at the orientation again, the entire city, in fact, just like walled city of Jaipur, was aligned in a grid which was running northwest to southeast and northeast to southwest, And if you look at the two major orientations of the buildings, one shown in red here along the Jan mark, either the buildings would again be placed in such a way that you have a longer side facing north to permit north light in the workspaces and shorter edges towards west and east. Another such built mass along the Madhya Marg. These all were workspaces. And then you have these residential zones, they're running, diagonally to the cardinal directions and benefiting from they sort of form a larger courtyard through this series of row housing. And they benefit from the wind direction as well as the building blocks because they are either exposing themselves to north and south more, or they will have shading devices if they are facing southwest and northeast. So with these two kind of, orientation maintained throughout the city fabric, you were able to make a livable, sustainable built environment. I'm saying this because I remember my mother saying this to me that before 90s, people never used to have or wish to have, cool air conditioning or coolers in those houses, especially the brick houses of Chandigarh. It was quite comfortable. Now, of course, you cannot live the heat island and surrounding peripheral development has completely changed the, the conditions for which it was designed. So other than the personal anecdotes, let me show you more on this. The images are sourced from a book documenting Chandigarh by Professor Kiran Joshi, renowned professor from Chandigarh College of Architecture. Um, Now, this is one of the image of a typical neighborhood block, the government housing, which is still, intact in some ways. How is this not in lines with the design decisions that were done for Hawa Mahal and City Palace? I mean, look at the orientation. Like, if you can relate this, the courtyard, the perforations, the blocks, and there's a continuity of a system throughout the city, which allows the wind, the sun, the shading device to work unanimously for a comfortable living environment. The scale of courtyards here can definitely compare with the uh, palatial courtyards in the wall city of Jaipur, the middle block of Jaipur. So my again the point is the wisdom remains the same um since last 250 years. Something has gone wrong. Uh, Again, more examples from the Capitol complex. The idea to show this is only to again talk about the orientation here. Look at the north sign, the building blocks running northeast to southwest, the longer side facing northwest because it's a workspace. It will be almost towards evening when the surface will receive sunlight. So ensuring, comfortable, uh, glare-free lighting and, shade from the sun. And the facade, which is exposed to sun, the facade which is facing southeast, has this dynamics of the shading, both horizontal and vertical. And if you look at this, that the wisdom that this shading has to be detached from the main building was very much there. Similar systems adopted for assembly and for high court, and high court also draws the same wisdom which was there in Golkund Ashram, that you need to have a double roof and allow the convection cooling to happen for the roof. Again, the shading systems. And if you look at it, the three buildings, few, not very far away from each other, but design is not limited. The design of shading device is not limited. The underlying principle, the underlying theory is perhaps same, but the expression of form, the expression of design in shading device is very, very different. So basically, the idea again here is that the same formulas necessarily do not mean that you will have the same monotonous, boring design. So look at the multiple expressions of shading devices that have taken place. Now, of course, everybody knows about this tower of shadow. It's a physical manifestation of theory. This is where I say the theory gets built. The understanding of solar azimuth, epsilon, wall azimuth put together, and you are able to devise a system of shading, horizontal and vertical, for both cardinal orientation and diagonal orientation. I'll quickly run through few examples because it's important to tell you that good sustainable architecture, sustainable not in terms of rating, because I don't think rating systems were available at that point of time, but architecture where the aspiration of becoming modern were met by using resources very, mindfully, by not throwing up the wisdom from tradition that orient your building correct. Shade the facades, shade the openings which are facing sun. So the General Hospital from Sector 16, Chandigarh, again, if you look at the orientation, the rooms open directly to the north. This is the north side. So if you can look at the way the spaces are designed, they draw light from the north side. The south side is shaded by clever use of corridor there. The corridor is open, allows the wind to, the air movement to happen. And it's persistent. The theory, the principle of climatic design is persistent throughout the hospital building. The block, which is, longer in north-south direction, actually gets punctuated by these other blocks. So actual portion which is exposed to sun is then reduced. The actual surfaces that are exposed to harsh west sun gets reduced. And of course, if you can see, the the treatment here by these jagged positions, surfaces, you create shade. The architect's office itself, again, following the same orientation, this being north. So all workspaces facing north. The side, shaded by horizontal means, by verandas. And on the other block, you have shading brise soleil, which casts shadow on both the glazing and the surface. And of course, it uses the stack effect to ventilate the rooms. There were no cooling mechanical device in this office where the entire city of Chandigarh got built. Now, this some old photograph of the same. Again, the principle again is orientation and shading the exposed surfaces, shading the exposed glazings. And how difficult is that to remember? Again, another example, university, arts college. Look at the line, diagonally to cardinal direction. The classrooms, each classroom gets the north light. That, you know, uses the corridor or an additional block. The rooms that face south, they or southeast or southwest, they have again the shading devices. Similarly, the southwest again gets the shading device in the guise of in the disguise of actually the corridor. Towards their later association, they also started experimenting with the building sections. So if you can see an inverted pyramid in section, the sort of a ziggurat. And what it does is, if you look at it, the north-south facades are then shaded using these horizontal shading means, and each story shades the story beneath. No area, no functional building was left. Every building was given the same treatment, same benefit from the theory of climatology, the understanding of climatology. No building was spared. They never thought, ki, oh, we are in a hurry, we do not have time. This is a smaller project. Why should we worry about this? No. Even a basic primary junior school, uh, the corridor, again, a means of circulation, but also a shading device. There are many schools that just took one. Again, look at the orientation, draw light in classroom from north, use corridors in the south. The corridors act as shading devices, and you have, minimum surface exposed to east and south. The photographs of the same principle, different configuration, different functionality. And the housing, one such house is where I lived. Another experiment, use of sunbreaker to shade the surface itself, which the surface especially which were, uh, facing south and southwest. Not even the peon's house was spared from the treatment or application of climatological theory. Again, if you look, the orientation mattered. North-south orientation, open spaces, shading devices. The entire city, especially the government housing, is a good example of variety of shading devices, perforated screens. And I'm using this word again and again, perforated, because this is what the revised manuals of rating systems talk about today. This is what those who are selling us the aluminum sheeting devices talk about it today. So my idea is to give you a connect that the wisdom was very much there. There was something happened, I don't know, that its application we don't see much in the recent last 2 decades. 1956 building again in Chandigarh. Sorry, I'm sharing a lot about it because the entire city had so many examples to talk about this climate responsive architecture. So, and it's also to open up the minds of younger generation that a lot of things have happened here in your own country as experiments. So this UT Press building designed by Maxwell Fry. Again, look at the orientation, northeast, southwest. So northeast facade has this glass glazing, which is openable. The first, you can say, call it the first glass building of India, maybe. Uh, and the southwest facade is here, the openable louvers, something similar that we saw in Golkund Ashram just 10 years ago. So this whole idea of movable, openable, fins on the south and southwest facade is very old. And these were aluminum fills, unlike in Golkut Ashram, where it was a concrete panel which used to, or ferrocement panel which used to move. Now, with that, my question is, and I may be overshooting the time a bit, Praveenji, but the thing is, where have we lost this theory or this understanding? Because when I look at Chandigarh, I think it became muted in between. So the lost, when I call it a lost theory, is because just 9 kilometers from Chandigarh, we see a development from 1970s and more so this one, especially in 2000 and 2020. Complete loss of this understanding of orientation right at the edge of the city. uh, you know, I will not name the localities now, but this you can see global on Google Map, and this is the evidence that something is missing. We are losing this theory, the very understanding of orientation. On the right side, I have this snapshot of Jaipur. The grid, I think, was lost as it expanded. There is no I would say, respect to the orientation later on. Reasons we all must find out why, but the understanding should be there. Now, the theory I'm sure you all have learned in your BR course, and what should be guiding you or the people, what guided people before us was comfort, definitely comfort, which can be subjective response. There can be many parameters. You can have cultural, psychological, emotional, economical, health factors that can influence your comfort levels, but one measurable, one which affects our working capacity, one which affects us psychologically also, and one which affects our performances is definitely the thermal comfort. which is represented, using this bioclimatic chart. And this bioclimatic chart gives us this range of 20 to 30 degrees Celsius as the comfort zone, which can be pushed further up to 35, 36, using air movement. And with the help of some heating devices, we can remain comfortable up to 10 degrees. So this very understanding of what comfort is not something that can be taught. I think we are born with it. But yes, one important thing to remember is that discomfort is becoming more and more subjective as the time is passing by. Like when I again call back to, look back to what my mom used to say, it also means that we were more resilient of the environmental conditions outside. We could survive without fan, we could survive without air conditioning or air cooler. I'm sure certain villages and some people still manage to live peacefully with environment. That also meant that there's something to do with user living sustainably. But technically, scientifically, if you are between 20 and 30, you do not need any additional device to become comfortable. But I have seen people turning on air conditioners when the temperature goes 24. Uh, what is the explanation to that? How can we be sustainable if we cannot be resilient? There are responses how we deal individually with the fluctuation in climate. Our comfort zone, within this comfort zone, can be subjective to our personal responses, and which is permitted, which is allowed. Some people wear more layers of woolen. Some people set the temperature to very low for the air conditioner, so and so forth. So yes, but yet there is a agreeable comfort zone, between 20 and 30, which in my opinion also does not require any mechanical energy consuming device. Another understanding that an architect must have is the material behavior and heat flow through them. Heat flows through radiation, conduction, and convection. Basic physics from school. Uh, Radiation at hot surface emits heat waves. Conduction, when two objects are together, the surface contact will allow heat to flow from hotter body to colder body. And air, when it passes over a hot body, can carry heat and pass it on to the surroundings and to the other nearby objects. And in the process, it is cooling the object which was hot, but it is depositing heat at some other point. And I'm sure these all diagrams are from the very basic, but the most important book called Manual of Tropical Housing, the Königsberger. And a beautiful, wonderful book which explains how a building exchanges heat. It receives radiation. It can receive or lose, through convection. It can allow for evaporative cooling through the roof from any moisture available on the roof. Occupants add to the heat. Any electronic or mechanical equipment inside will add to the heat. And in this equation, when we sum total all the heat gains and heat losses, if the equation is zero, we say the entire exchange is in equilibrium. The positive value would mean that the building is gaining heat, and negative means that the building is losing heat. So negative value will definitely be experienced in cold climates, while the negative positive value in tropical zones, especially in countries like India. So a big common is that in climate, solar radiation is undesirable on the building. If you look at this diagram, if you can block this, your equation will remain in equilibrium. Conduction, undesirable With time lag, the heat from the outer surface passes to the inside. If you can block it, you can avoid heat gain. Similarly, if the temperature outside is higher than inside, then this convection ventilation is not desirable. But if the temperature outside is less and lot of heat has accumulated inside and your internal air temperature is higher, then definitely you can benefit from convection cooling. Definitely all the equipments in the room will add up to heat. So less is more. The I mean, it's not in scope of webinar to introduce or with all the theories, but I'm assuming you all know that we have formulas, three basic equations for convection, radiation, and conduction. I have colored them separately because if you can practice with these equations, I can share this PPT with everyone later. You will find out that the maximum heat gain is through radiation falling directly through the glazed window inside. And the second major factor which allows for heat gain is conduction. And convection is very subjective. It depends on whether you have openable windows, whether you're using outdoor air to cool, etc., and so on. So the most important factor which determines the heat loss or heat gain, depending on the climatic zone, is radiation. And with the area, the radiation intensity, and the material properties of glass, one can calculate it. Calculations can also be done through softwares. I mean, I'm not against them, but understanding this fact that radiation is the major culprit, save your building, protect your building from it. The surfaces, the roof, the glazings from direct exposure to radiation. That is the wisdom. And through the examples that I started in the very beginning, I'm sure you can recall that most of the building, whether it was Gokun or High Court or school building or university building, the surfaces of the building were shaded by using another structures, which we call shading devices, and they functioned as connectors, corridors, or just the shading, brisole. The strategies, of course, in simple terms, avoid solar radiation, use materials which have low U value, that means that do not allow conduction to happen, and minimize hot wind exposure, avoid direct opening of window to external environment if it is hot. But if your outside temperature, especially at night time when it is cooler, you should allow the opening of windows. So openable windows are always better than the closed ones, and you should allow convection to cool your building during the night time. And as I said, the first point, the first factor is the major culprit. And only two thumb rules, how difficult they are to remember. Orient your buildings, especially in tropics, in such a way that you have minimum windows in east, south, and west direction, and you can maximize the windows in north direction, right? And you have to then devise shading devices using sun path. Now, sun does not always rise in east and does not always rise, sets in west. It's dynamic, and that's the beauty of life on Earth. The seasons, the annual cycles, depending on rotation and revolution of Earth. The major factor is the tilt of the axis of rotation to the plane of revolution by an angle of 23.5. And that's what happens is that when the Earth completes the circle, the extent where we get the perpendicular radiations, it keeps shifting from Tropic of Cancer in north during June to Tropic of Capricorn in December. And this is what happens to the buildings, in summers, they will have shorter shadows, and in spring and fall, sort of they enjoy the equal days, and in winters you have long shadows and inclined radiations. So the same building, same built environment is exposed to differential settings, and this is the very way in which the the entire solar system and Earth and its revolution and rotation works. So we have to keep that in mind while we are designing our building. So all it means is that we are not looking for one answer or one solar azimuth or one solar angle, but we are looking for a range of angles for that range of periods. So especially the overheated period in northern zone is during summers between March and October. And that's when we can design our shading devices. The the wisdom has to crystallize to the very basic reflex action of human being, and I'm sure you all can hold an umbrella and point it towards the sun throughout the day and every day throughout the year. So if formulas scare you, if formulas and the terms scare you, I think you need to train your mind to understand that it is not so difficult as it seems. It is subjectively as simple as knowing where the sun is and holding the shading device against it. So technically, what we have done, I mean, the experts have done is that they have this assumption. There are a lot of assumptions. We assume that Earth is flat. We assume that the sky above a point on this Earth is like a hemispherical dome. And the observations of sun's position are marked on daily basis. Each day, the movement of sun can be traced on this imaginary sky dome, and that path is called the sun path. Now, why I'm saying this is that it is definitely different than the kind of diagrams we saw in the beginning, and that usually that we see. So this is definitely an assumption that there is a sky dome represented by a hemisphere, and sun's movement is traced, and this trace line is the sun path. You can have it for each day. You can get them generated over computer. There are so many online softwares available. Getting them is not an issue. But what is important is to understand that this sun is making a three-dimensional angle, and it has two-dimensional components which are useful for us in designing the shading devices. Like any, I'm sure you all have studied law of forces, the resultant of forces. So basically every um, quantity can be resolved into its constituting quantity. So a three-dimensional angle can be resolved into its constituting two-dimensional angles. And objectively, how do you understand it? The position of the sun in the sky is making an angle with that point. Now that point, when the observer standing and looking at the sun, that trace can be measured from the north direction. So the north direction does not change. So from taking north direction as the reference, if you mark the position on the ground by taking the trace, the vertical trace down on the surface. That angle between the north and the sun's direction, the horizontal trace, gives us the solar azimuth angle. It basically tells us where is the sun on the ground with respect to north. And similarly, when you're looking towards the sun, it is definitely, marked in orange. It is giving us the vertical angle, the altitude angle. And that tells us basically how high the sun is from the horizon. So with these two informations, we can easily find the total solid angle for the, accurate positioning of sun. We see that in equatorial zone, the sun paths will mostly remain overhead. The traces from the sky dome when they are, placed, the summer and winter sun would predominantly show the higher altitude. The solar altitude angle would range between 90 to 60 degrees. In the temperate zone, especially where we are, we will experience major variation. In summers, we'll have sun exhibiting high altitude, uh, close to 80, but in winters it will go down to 45 to 60. So that's the variation. And again, in polar zone, the annual extent of solar paths will remain at very low angles. So with this imaginary assumed device, one can trace the position of sun, uh, and they are already ready-made and they are available with Indian Meteorological Department. For accuracies, you can also get them generated online through various softwares. There's no need to name one, there are so many. And there is a and how is this, represented in a two-dimensional diagram? It's a stereographic representation. You use the same system of, horizontal and vertical curvilinear lines on the hemisphere to mark the position of the points. So in the stereographic projection, if you look at this 3D, the concentric circles, they tell us the altitude, how high we are from the base of this hemisphere. And these vertical curved lines on the surfaces, they are actually radiating and shown as the angles starting from north direction in clockwise direction on the periphery of the circle. So this top view of the dome contains both the information to measure azimuth and information to measure the scale to measure the azimuth angle. So in this example, if the sun is marked here, has having an altitude angle of 52 degrees. And if you measure from north, the sun is at 180 degrees azimuth, which means it is directly at south. So for example, if we take these solar charts, there is another alternative solar chart, which is like the elevation of this dome. But both charts work equally. This is more useful for shading devices. So if you take an example of a solar chart, the solar chart for each latitude would differ, but it would remain same for that particular latitude. And if you take, just for an example, if you want to find out the position of sun on a particular date and time, you can use the stereographic projection of that sky dome. And the solar chart also has the hourly lines, starting from the morning at 6 a.m. till 6 p.m. marked on this chart. So all you have to do is look for the date curve. So in this example, the date curve would be this line, 21st March. I hope you can see that on the screen. And we have to look for the time curve, which is 10 a.m. So this position where my arrow is the location of the sun, and you have to connect that to the center, extend it to the periphery, read the azimuth angle, starting clockwise from north, and it comes to 131 degrees. Just read the scale. Similarly, the position of the sun here is between these two concentric circles, which represent the altitude. So it's between 40 and 50, and it's closer to 50. So it's 48 degrees. So solar chart, which definitely looks like this and not like a smiley, is a device. It's a tool for any designer to find out the solar two-dimensional angles, the horizontal azimuth angle and the vertical altitude angle. Once you know these two values for a particular location, date and time, you can get the angle of incidence, the three-dimensional angle, by multiplying the cos factors of these two angles. The cos gamma, basically gamma is representing the altitude angle and azimuth is represented by alpha. Multiply the cos factors and you get the cos factor of the total solar incidence angle. You need this total angle to know the intensity that is falling on the surfaces or on that point on the surface. Now, mind you, we did all this to find the intensity of solar radiation on a point on the surface of the earth. If we want to find the intensity on the wall, we need to find the angle between the wall surface, the perpendicular to the wall surface, and the solar incidence angle. So what is a wall azimuth? Just like solar azimuth, wall azimuth is basically guiding us, telling us the direction of the wall surface with respect to geographical north. So the perpendicular to the wall surface, which we want to calculate the shading device, we need to find out the angle between north and that perpendicular. So some pre-calculated, answers would be like wall azimuth for north-facing wall would be 0. For east, it will be 90. For south, it will be 180. For west, it will be 270. And for the diagonal positions, like for northeast, it will be 45 degree. For southeast, it will be 135. For northwest, it will be 350. While for southwest, it will be 225 degrees. So getting to know a wall azimuth is not a very difficult thing. Wall azimuth, again, is the horizontal direction of the perpendicular with respect to north. And we need to know this because we want to know what is the angle sun is making to the wall. Previously, we found out what is the angle sun is making to the point on the surface of the earth. Both are different, both are required, but this is more important to know the angle between the solar incidence and the wall surface. And how do you get that? You again get by changing the equation. The altitude angle remains same, but the difference between wall azimuth and solar azimuth gives us cos delta, and the product of it gives us the incidence angle on wall surface. It may sound complicated, but if you understand it subjectively, it is not that difficult. And once you know this three-dimensional angle of solar incidence, you can resolve it again backwards to find out HSA and VSA, which is the horizontal shadow angle and vertical shadow angle. The horizontal shading angle is the difference between the wall azimuth and solar azimuth, which you already calculated. And the vertical would be the component of this vertical angle on a plane which is formed between perpendicular to the wall, a plane, sort of a plane perpendicular to the wall. And you can use trigonometry. The formulas are available. And that angle, vertical shadow angle, is epsilon. And you get it by multiplying tan of your solar altitude angle, secant of your azimuth difference, and that gives you this vertical shadow angle. Vertical shadow angle helps you design how much should be. So if you know the epsilon, 90 minus epsilon is what you need to draw in your section to find out what is the depth of the horizontal shade. Like in this photograph, if you see this huge cantilevered pergola is acting as a shading device for this wall. And it has a cutoff angle, which definitely can be calculated using these formulas. Similarly, the altitude, this azimuth difference gives us the horizontal shadow angle. And 90 minus this delta will help us design this width. Same must have been applied in the photograph that you see. I'm overshooting the time, Praveenji. Do you think we have time to continue? I can wind, I need just like 5 to 10 more minutes maybe to wind up. Praveenji? Should I continue, Praveenji? Anyways, so just an example of, you can take values for a date, a location, and you can calculate the angles. In this example, using the same technique, you find out the solar azimuth, you find out the uh, solar altitude angle, you find the difference between, if this is representing the wall and this is perpendicular to the wall surface, the difference between these two angles is the delta. Once you have delta, using the formulas which we saw in the previous slide, you can calculate the epsilon, which is the vertical shadow angle. And using these two values and subtracting it from 90, you can use trigonometry to get the widths. Now these widths are, they look absurd, but then they are the requisite widths. Like for example, in the previous, this huge depth is required if you want to shade the surface by a single horizontal surface. Similarly, this width of the vertical would be required to, if you want the entire surface to get, shaded. But then there is a smarter way. You can break the surface at smaller intervals. You can have what we call fins or shading fins in a way. You maintain the same angle, you maintain the spacing in such a way that the angles that we calculated remain maintained. You can have combinations of vertical alone or horizontal alone, or a brise-soleil or a recreate where you can combine all together. But no matter what you design, the delta, the theory behind delta, epsilon, and the azimuth difference does not change. It does not change in 1727. It does not change in 1822. It does not change in 1950s, and it does not change in 2020. So, so there's, this age-old wisdom, age-old theory you need to master. And I would say, don't rely for the software understanding. Rely on your own understanding, because I see that because of software, relying on software, on ground reality, we are missing on the wisdom. S- These are the recent efforts, the hexagonal are good, and there are some experiments done in some of the universities working on shading devices. Now, the thumb rules and wisdom that I want to close this presentation on is that your static shading device is more sustainable because it does not require any energy, any electrical energy to move. Any moving component means it will have, it will require energy. Of course, if you can, back it up by energy production, definitely, you can use them. I mean, mechanically or electronically movable fins are best because you can keep changing the direction as per the direction of the sun, but they are energy intensive. Otherwise, the static shading device, they are quite good if you are good with your angles. And brise-soleil, which is the combination of vertical and horizontal, that is definitely better. But few things that you must keep in mind is that the problem which happened in 50s and 60s is that some of the materials selected for shading devices did not have low U value. They had the same, uh, like I showed you in Secretariat, the shading device was separated from the main wall, but how many of the buildings which were later made could do that? So if you connect your shading device with the main wall, due to conductance, the heat will get transferred to the main wall. Similarly, if your shading device is made up of material which is absorbing heat or good conductor of heat, it is not going to give you, it is going to indirectly add heat to your body, to your building, but of course it is providing shade. So one important thing is that your shading device should be detached from the surfaces that you're trying to shade, and it should be of low U value. Aluminium definitely, wins the battle, but then there are other ways in which you can, there are other materials too that you can use with certain paints. Your shading device, if perforated, it's good because your shading device is also receiving, it's the first one, it's like your umbrella, it's receiving the radiation. So if you allow convective cooling, of your shading device, it will be better, less chances of heat conducted to the main building. And some which you can call contemporary, but I see their roots in the past. The material with lowest U value perforated with the gaps to allow this is the latest trend. But one must also understand that glass is was never used traditionally in India. We never used glass. It's only in last few decades that it is being used as an imitation material. Europe, we know, wants to have heat gain in their buildings. So definitely they sell these expensive systems to us. They push us to use glass and then use this perfect shading device made of aluminum, which is perforated. I mean, as per the theory, if you know, and if you can calculate the angle, if you make them movable, yes. But why use glass in the very first place? That is something that you must ask yourself. And if you're using glass, why don't you use it on the north face or the faces which do not, receive solar radiation? Some, pre-built shading devices in the aluminum frames, being marketed now. Now again, they are very good, but the what I'm questioning is that why we put our glass to the south face? Why do we have windows to west and east? Where do we have such huge glazings? Why do we first expose ourselves to radiation? Of course, the theory implemented here, the only change here is the structural system. The previous systems used very basic column beam sort of a structural system for self-standing shading devices. These shading devices become structurally more efficient, but again they are on glass. Uh, so what I want to sum my presentation is that present is the contemporary is a continuity from past. The wisdom which was there 200 years ago, 100 years ago, still continues. The expression can change. Now you as a student must master the thumb rule that what should be the orientation in tropics. And second, you must know the solar azimuth, wall azimuth, and the altitude angle using solar chart. If you can calculate that, you can have multiple expressions of shading device. You can devise many structural systems for them, but the purpose is same. The purpose is thermal comfort. The purpose is to keep the exposed surfaces protected, shaded from the sun. Thank you.
Thank you, sir. Thank you,
Thank you
sir.
for the patience because it went on and on. I know I overshot it time.
It's a wonderful presentation. I think it will help our students. And now I would invite to our faculty member, Mr. Architect Abhishek Sharma, to share his view on the presentation. And Abhishek sir?
Okay.
Yes, sir.
Good afternoon, sir. I really thank you on behalf of my university by sharing your these valuable thoughts towards the sustainability, and also your knowledge regarding the sustainable techniques through case studies, along with the calculations, to give this in a presentable way to the students, so that to enforce or to aware themselves about the uh, use of this sustainability into their design, by noticing the present scenario of the globally, I would say, to the atmosphere, and to think about the future also, to use the usage of the resources, and to by using these sustainable techniques. I really thanks to you, and I hope that the students will definitely they have been guided by your this webinar, and they'll definitely use this sustainability approach in their designs in the future and in their projects also. Thank you so much, sir.
I wish the same for them. It's just three angles and the orientation. That's all. That's all that makes any building sustainable.
Yeah, sir. These the climate responsive techniques were also helpful in your this presentation also. It was good. Thank you so much, sir.
Thank you. Thank you.
Thank you,
Any
sir.
questions? We can take some questions if we have time.
Yes, sir. We have many questions from our student side. But before this, our two students want to present their presentation. So I would like to invite Mr. Abha and Mr. Rishabh to start your presentation one by one. Abha?
Hello.
Hello. Abha, you can start your presentation.
Okay. Am I audible, sir?
Yes, you are audible.
Okay.
Please share your screen.
Yes. Is it visible?
Yeah, it's visual.
Good morning, all of you. Good morning, respected faculty members and the guest of today, Architect Abhishek sir. Your presentation was very much knowledgeable for us. And from some knowledge which we have prepared a presentation. I've prepared something on sharing devices, what are sharing devices and how we can use it. So sharing is a key strategy of achieving thermal comfort in summer. So we have three tiers of design, which in the first tier we have shading and light colors. Second is passive cooling, and third is the mechanical cooling, how the building reacts to them. And we need shading devices to maintain a balance between underheated periods when solar radiation is beneficial and overheated periods when radiation should be avoided. So as this table shows that how the windows or the skylights or the direction of the windows requires shading. So the south windows, the shading is desirable as from a shading and a passive solar heating point of view. And in skylight, the shading is undesirable as it collects a great amount of solar radiation in the summer and little in winter. The east and west windows, the shading is undesirable as not desirable from a heating and cooling point of view, as the radiations and the heat in east and west are straight coming into the building. So we have three components of total solar radiation. First is direct radiation, second is diffuse radiation, and third is the reflected radiation. So as it shows that direct radiation is the solar radiation transmitted directly through the atmosphere on the building, and the effective control technique is that exterior shading devices are required. In the diffuse radiation, solar radiation that has been scattered by molecules or suspensinoids in the atmosphere, they react on the building. So it needs additional indoor shading devices or shading with the glazing. So the reflected radiation, the solar radiation that has been reflected by clouds, the earth surface, or the surroundings around our building or the built environment. So reducing the reflectivity of the offending surfaces, that is use of plants or the softscapes near our building. So exterior shading, it is greatly preferred over interior shading as it is important to keep the solar radiation or heat and to stop the solar radiation or heat from entering the building. In the first image, we see an overhang which is helping in no direct sun as the no direct sun enters the space. And internal shading, it has curtain in which sunlight enters space and heat builds between curtain and the window. Then in the third image, we can see the blinds within double glazed windows. Heated air builds in the window itself and it's exhausted to the exteriors. So there we have some examples of fixed shading devices. So we have overhang horizontal panels, overhang louvers in horizontal plane, overhang horizontal louvers in vertical plane, and overhang vertical plane. So we can see in section how the four types of fixed shading devices are placed in front of the window or the opening of the building. The conclusion which we can derive from it is the overhang horizontal panel traps hot air and can be loaded and by snow or wind. That means it can have a dead load on it during certain atmospheres. And overhang horizontal louvers, they have a free air movement. No snow or wind load is small and it is on a small scale. Overhang horizontal louvers in vertical plane, it reduces length of overhang. View is restricted, also available with miniature louvers. We have overhang vertical plane. It has free air movement, no snow load, but the problem is the view is restricted. Some other examples of fixed shading devices: vertical fins slanted on a certain angle. and egg carrot with slanted fins. These also have their properties. The vertical fins has the restricted views for north facades in hot climates only. Vertical fins slanted towards north, restricts view significantly. Egg carrots for very hot climates, view very restricted, traps hot air. And egg carrot with slanted fins, slant towards north, very few view very restricted, traps hot air, and for very hot climates. Some things about orientation of shading devices, like each orientation requires a different shading strategy. The horizontal overhang or south facing windows is very effective during the summer. So for more effective fixed shading devices, a combination of vertical and horizontal elements should be used. So when we talk about east and west facing windows pose a different difficult problem because of low altitude angle of sun in morning and afternoon. So the solutions which we can provide is to solution one is to avoid using east and especially west windows as much as possible. Solution two is to have windows on east and west facades face north or south, which is shown in the figure 6. And solution 3 is to use horizontal overhangs or vertical fins. We have movable shading devices. Need for movable shading devices are thermal conditions not in phase with solar angles, sun angles symmetrical about June 21, thermal mass effect of Earth. So these are some reasons that we can have movable shading devices for different parts of the year and different time in the year. We have some example of the movable shading devices as we saw in Sir's presentation also. So some basic examples are overhang awning, overhang rotating horizontal luvers, rotating fins, egg carrots, rotating horizontal luvers, and fixed vertical luvers, deciduous plants or trees or vines near our built environment, and exterior roller shades. So overhang awnings are just fully adjustable for annual, daily, or storm conditions. They trap hot air, and they are good for view also. Rotating horizontal louvers block some view and winter sun. Rotating fins, they are much more effective than fixed, less restricted views than slanted or the fixed fins. Rotating horizontal louvers, view very obstructed but less than fixed egg air for very hot climate only. Trees or vines, view restricted by attractive for low canopy trees, and the air and the microclimate is affected by the vegetation or the trees which are used for shading. And exterior roller shades, they are flexible form, completely open to completely closed. Views restricted when shield is used. So some movable shading devices, we can see awnings in the image also. They can be removed in winter. They are automated, manual, and the deciduous plants responds to temperature changes, low cost aesthetic qualities, glare reduction, visual privacy, cooling by evaporation. They are having slow growth, limited height, and possibility of the disease or the decomposition of these. So shading devices for windows, for south windows, horizontal louvers, which allow snow and rain to pass through, minimum collection of hot air. Louvers in a vertical plane are appropriate when the projection distance must be limited. So in this image, we can see that the length and of the projection also changes the shade which comes on the window. The sun comes from the southeast before noon and southwest afternoon. Thereafter, the sun will overflank and overhang the same width as a window. Narrow windows needs either a very wide overhang or additional vertical fins. Wide stripped windows are affected less by the problem. And in case of east and west windows, it's like impossible to fully shade the summer sun with a fixed overhang. Little winter heating expected. The design purely on summer requirements. Horizontal overhangs. Best combination of view and shade must be much longer than the south. Should be backed up by another device such as Venetian blinds. So in the image, we can see that solar penetration is reduced by moving fins closer together and making them deeper, or we can use either both the techniques. The vertical fins, they obstruct views much more. They can control direction of view. Movable fin allows somewhat obstructed views, must extend above the top of windows or be capable with an overhang. Thank you so much, sir.
Thank you, Abbas. Now I would call to Rishabh. Rishabh Swaroop. Rishabh Swaroop, are you ready?
Hello, am I audible, sir?
Yes, yes, sir. Meanwhile, I also request to Architect Aman sir to please be ready with all questions which we received from our student side. And now, Rishabh, you can continue.
Okay, sir. Good afternoon, all. I am Rishabh Saru, and I am going to present an abstract on sun path. Although sir has already given a good explanation on the sun path, but I am going to present my form of it. So, the angular movement of sun at any given point of time in the year. Sun path refers to apparent significant seasonal and hourly position changes of the sun and length of daylight as the earth rotates and orbits around the sun. Sun path diagram, as the name suggests, is something that is used to determine the location in the sky of the sun at any point during the day throughout the year. Use in functional design. The most immediate use of sun path diagram is that the solar azimuth and altitude can be read, and hence the position can be exactly determined. Some important terms: azimuth angles. Azimuth angles run around the edge of the diagram in 15-degree increments. A point azimuth from the reference position is measured in clockwise direction from true north on the horizontal plane. Altitude lines. Altitude angles are represented as concentric circles, dotted lines that run from the center of the diagram in 10-degree increments from 90 degree to 0 degree. Date and month lines. Date lines represent the path of the sun throughout the sky on one particular day of the year, which start on the eastern side of the graph and run to the western side. There are 12 of these lines shown for the first day of each month. The first 6 months are shown as solid lines, that is January to June, while the last 6 months are shown as dotted lines, that are July to December, to allow a clear distinction even though the path of sun is cylindrical. Hour lines. Hour lines represent the position of the sun at a specific hour of the day throughout the year. The intersection point between date and hour lines give the position of the sun. So steps to read sun path. Step 1, locate the required hour line on the diagram. Step 2, locate the required date line, remembering that solid lines are used for January to June and dotted lines for July to December. Step 3, find the intersection point of the hour and date lines. Remember to intersect solid and dotted with dotted lines. Step 4, draw a line from the very center of the diagram through the intersection point out to the perimeter of the diagram. Step 5, read the azimuth angle taken in clockwise direction from true north. Step 6, trace a concentric circle around the intersection point to the vertical north axis on which is displayed the altitude angles. Step 7, interpolate between the concentric circles to find the altitude. So this is a stereographic representation of Sunpath diagram where these are our azimuth angles. The vertical line shows the altitude angles. The solid lines are for the first day of each month, and the dotted lines are for the first day of the July to December. These are our hour lines, which are in solid, and these are our lines, which are in dotted also. Thank you.
Has anyone any questions? Abhishek sir, I have one question from our third year student. He want to know that what are the essential parameter of passive solar designs. I think he got the answers. Abhishek sir, are you there?
Yes, I was
Yes, sir.
muted. Yes, I
Yes, sir.
could not. Uh, well, I think, see, solar passive or solar responsive means that depending on our location and our climatic zone, we make the best use of radiation or we best avoid the radiation. I think if this thumb rule is clear, you
Yes, sir.
cannot go wrong. If we are in cold climates, with sub-zero temperatures or temperatures, I would say below 15 degrees, we would prefer solar radiations to fall on our building surfaces. We will use materials which will absorb heat, conduct heat to the inside, make the interior warm. I'm talking about colder climates, right? And just the opposite, just
Yes,
the
sir.
opposite, like day and night. If you're in the hot tropical climate where the temperature is above 25, 30, I'm saying 25, even though the thermal comfort zone says 20 to 30 as a comfortable zone. But what happens is, I mean, we did not have enough time in the webinar. but there is a time lag. What happens is the material of the outer envelopes keeps absorbing and conducting heat depending on its qualities. If it's a perfect reflector, then it's a different ball game. But otherwise, the heat will be conducted towards inside over the time and get accumulated inside. So therefore, for the hot climatic zone, the lower reading of the bioclimatic chart, which is a 20 degrees Celsius, is taken for design. So for that, basically, we should avoid materials which have, uh, you know, uh, high U value. U value means transmittance. Resistance is the opposite of transmittance. So you should avoid materials which allow the heat quickly, like glass. Very few expensive glasses are claimed to be reflective, heat reflective as well. But the kind of budgets we the clients have, and majority of the buildings, we don't end up using those glasses. So a thermal barrier to conduction and radiation is required in hot climate. So mud has very low U value. Then next, brick. Best is of course mud, but then for durability you can go to brick, concrete, other blocks. Uh, but even these materials which have low U value, over the time they will become heat bank. So in old times, the thermal barrier was provided by increasing the thickness of the wall. You offer more resistance to the heat to reach inside. Then next level is that you shade, and that is what we saw a lot in 50s and 60s architecture, especially in tropics, that the theory of shading the surfaces and the glazings to block the radiation, double roofs, they were, so it's like one time investment. The shading devices, the standalone self-standing structures detached from the surfaces, they're one time investment. But if you look at the running life cycle cost of the building, when you reduce the heat load getting inside, you are definitely making it solar responsive. And of course, with the development of solar panels, you can also club the shading devices because shading devices are going to be on the surfaces which are exposed to solar radiation. So if you can, I think that is the future. If you can club the shading devices with piezoelectric material, you can shade and generate electricity. So that can be the next and a lot of work is already happening towards that. But orientation, I think, what I am again emphasizing is the first step is when you are planning your blocks, the very first step of orienting your block right, designing a block in such a way that you have smaller surfaces exposed to east, west, southwest, southeast, and you have longer surfaces facing north and south, or northwest and northeast. You actually may ensure that your project is solar responsive. 60% chances that you have taken care of it. Second step is choose the right material, low U value, high resistive value. uh, Outer surfaces reflective of heat, they reflect heat away, but I also do not recommend that, because what happens is you should also be considerate about the external environment of the pedestrians, because when you use a lot of aluminum and a lot of this reflective glass, what happens is the areas outside the building, which could have been shaded, which could have been usable outdoor environments, they suffer from additional reflected radiations, they suffer from radiated reflected heat. So I think why I still have this love for this 1950s and 60s building materials is that not only they were using the same principles, but these materials were also comfortable for outdoor environments. They were not adding up heat to the outside. So one must be very careful, when we use these high and expensive materials. Of course, in laboratory, aluminum is good reflective material, but also understand the practical implications of the outdoor vicinity in, what is going to happen there. I see a lot. I mean, you stand outside of World Trade Park in Jaipur during
Yes, sir.
between 12 and in the evening. You will
3 o'clock.
yeah. So you will, yeah. So you will understand what I'm trying to say. So not only the building is gaining heat, but the outside area has also become, non-usable, inhabitable, and in fact more difficult for the person who is out there. So for solar responsive, I think the choice of material, orientation is very, very important. Low U value is the key, thermal barrier is the key for the hot. And just the opposite in the cold climate. Open your building, open your inside to the solar radiations in the colder climates, and you're good. Convection,
Sir,
the air movement is very tricky because if done correctly, it can help you. If done wrongly, it will disturb the heat balance of your building. Yeah. Yes, Praveen sir.
sir, one more question, and it's very interesting and challenging from our student side. How to get more of sunlight in the small houses, like row houses, with no setbacks and packed from three-sided?
3 sides.
Can you come again, please?
How to get
Uh,
more of sunlight in the small houses with no setbacks and packed from three-sided?
Okay. I'm not sure if you want sunlight or you want daylight. They are two different things.
Yeah.
If you want daylight in hot climate, you have to then, use skylight. You have to see, even you if your plot does not have height restriction, even in the smaller plot footprint, I would say go vertical, allow space for cutout even in your small plot so that you can draw light from the top. So light well can be one of the ways to get light in the areas which are away from the front. I know what you're talking about. So, and of course, use the front uh, for maximized, glazing. And of course, if it faces the wrong direction, then you will have to use the shading. Shading device can be created for any orientation. It's just that when you orient it right, you can minimize the need for shading device, then you can minimize the heat gain. Sunlight you would like to get in colder climate, but I hope you're talking about daylight in the hot climate. So the light wells, the vertical shafts to get light. And I think the old city of Jaipur does it well because each house is compact and it has this internal courtyard that draws, very nice daylight without glare. I have been into few homes. I got a chance to when I 2 3 years ago. So every house actually, banks on this almost 10 feet by 10 feet cutout shaft, which goes in those old houses. And they are, G+3 or sometimes G+3.5 high. And you get a very good controlled daylight inside. So I think that can be done for such area.
Aman sir, have you any questions? Aman sir?
Caesar having a one question.
Yes. Sir.
Nandan sir, please unmute Lalima Gupta from third year.
Yes. Nandan sir, please unmute. Lalima Gupta.
Lalima Gupta is not here. Lalima Gupta. No, sir.
Aman sir, she is not here. You can ask question from her side.
Okay. Her question is that how solar panels and solar farms can be extensively used at large scale, like town planning and city planning level.
Solar farms and solar panels. At town planning level, I only see a link with the grid. Like if you can convert the existing power houses which are using conventional sources to generate electricity, if you can convert them, and of course, if you look at the surfaces available at the city level, both the built and the unbuilt, if you can, through some policy for the surfaces which are already in control of government, like the government buildings, and for private, if you can promote the installation of these panels, and I think that, as I said, the next level is to club the shading devices with the solar panels. And a lot of work has already been done at city planning level. Uh, that's the only connect I see. And uh, like as I said, like the orientation, if of all the blocks at the city level is complementing to each other, then of course it will be easy for you to have these installations on the buildings and on and in solar farms if you are creating. The major challenge in especially the footage that I showed of the new developments which have no idea of orientation, direction, how the cities are expanding. The problem is your like it's so easy to, like when I say it's so easy to do this solar panel installation at a larger scale cohesively in old city of Jaipur and maybe in Chandigarh, but very difficult to do in Zirakpur because the thing is your build shape, your build form, build orientation will not go with the direction required for solar panel. The beauty is that sun angle is same for both, for the shading device and for the solar panel. So at pan level, if you're talking about collaborative, collective efforts, then I think the policy should promote everybody's participation and inclusion at the power generations level. You should have replacements. And I think architecturally or if morphologically, if you see from the top, if you have uh, the fabric which complements the built up which complements each other, I think it will be far easier for you to install such panels and create paths.
Thank you, sir, for the answer. And there's one more question from second year student Ritul Sharma. Nandan sir, can you please unmute Ritul Sharma from second year? Ritul Sharma.
Name. Just not short proper name. Ritul Sharma.
Ritul, Ritul Sharma.
Yeah. Just a minute. Yeah. He's unmute.
Ritul, can you hear?
Hello.
You can ask your question from Sir Ritul.
Yes, sir. Sir, how solar radiation and heat varies when we go vertically on different floors levels in any building?
Can you come again, please? I didn't get the first part.
Okay, sir. Sir, how solar radiations and heat varies as we go vertically on different
I
floors
didn't get the
levels?
second word. Heat, what?
Solar radiation and
Varies.
heat varies
Heat varies. Okay. As we go vertical. Okay.
on
Please.
different floors in any building.
Okay. Now, I don't know if you saw the presentation. So solar radiation intensity definitely increases as we go up in altitude. But that altitude is, I'm talking about, say, 450 meters above sea level, 800 meters above sea level, up to 3,000 meters and above. So I'm sure if anybody of you have done mountaineering and if you go to Ladakh, which are high altitude places, you definitely receive more radiation. That happens because of the atmospheric envelope. It gets denser as we go closer to Earth's surface. So radiation definitely increases when we go up, but that magnitude of the height is quite a lot, like 450 meters and above, 600 meters. So if your high-rise building is not that high, I think the only perhaps building which is 800 meters, it might have this differential radiation from on its top story to the bottom story. But if you are within the range of even up to 100 meters to 150 meters, the amount of solar radiation and differential heat gain is negligible. In fact, it is not considered. All the exposed surfaces will have same intensity, but it will be multiplied by the angle, the solar incidence angle, because that if the radiations are perpendicular to the surface, you get the maximum intensity, but if they are at an angle, the intensity reduces by the cos factor. So radiation for most of the practical calculations for the high rise that we are talking about, their solar radiation intensity remains same. But of course, if we are making a building which is 800-meter up, definitely will have more heat gain on the top. And another thing that you perhaps are talking about, of course, the top story, which has the roof exposed to the radiation, it will have more surface area to gain the heat. So that's why you hear people and everybody say that the top story would get more heat. That is because in the vertical building, the top story is the only one to have a roof which is exposed to radiation. All the other subsequent floors get shaded naturally by the floor above.
Okay, thank you, sir. There are
I
two
hope
more students
you have
from
good
final year.
class. Yeah.
There are two more students which have some,
Sure.
which is some confusion from final year. Sahid and Himanshu Swami. And then, sir, can you please unmute Sahid
Yeah, sir.
and Himanshu Swami also?
Now he's unmute. Shahid.
Hello, good afternoon, sir.
Good afternoon.
Sir, yes, sir. My question is, if somebody uses glass in the outer facade, such as in most of the skyscraper we see, glass is being used, and if the building can manage it from is inside, they are not economically here. The building can manage it. Like in Dubai, most of the skyscraper have glass facade, and India also. So what's the problem? If he can manage it from the maintenance, he can maintain his building. So what's the problem for using the glass?
No, I see. Listen, I have no problem with glass. You use it, please do use it, but don't use it wrongly. Like my problem is when you give a glass facade to south face or west face and
West
east,
face.
and then you do not give any shading protection to it. That is my problem. My problem is not the glass. You provide glass. In Chandigarh, I think, as I just told you, the first class building I can claim in India, perhaps.
Yes, sir.
The facade is facing northeast. It gets solar radiation only for 90 minutes in the morning. And then you get good daylight throughout the day. It is not giving you heat inside. Similarly, the A.C. Joshi Library in Punjab University, it has a northeast facing facade in the library. It draws beautiful daylight in the double story of the library throughout the day, but it has sun shading device for the northwest sun. So you provide glass, but you depending on which surface it is applied on, how exposed it is, you apply shading device. Now if you do not apply shading device, what happens? Sun is going to radiate, building is going to absorb. If you are not using glass wisely, if it is not a reflective glass, definitely you have high heat gain. You can build a building, you can pump a building with cooled air throughout its life. You can do it. And you can also show me an Excel sheet or balance sheet by saying that, oh, you generated electricity using solar energy itself. Your balance sheet comes zero. That means you have not spent any money on energy. Fine, be it. But still, I think the glare that you get from a glass building which has no shading, it is uncomfortable. The question here is how comfortable you are. How comfortable you are inside the
And
building.
sir,
You a comfortable environment inside, I'm okay with it. You give me a sustainable solution. That means if you have money in your pocket, you have energy which is renewable, I'm okay with it. But if you're in problem, if you're crying, we don't have energy. If we are crying, we cannot give buildings to poor because construction is very costly and you are not comfortable as a user, there's a lot of glare inside, then we must question why are we using it? Why are we doing it? That's all.
but sir, when the construction of skyscraper is concerned, then every skyscraper we see is the outer facade is made of glass. We can't use brick or any other material to made a sky. In future,
No, no, no.
more skyscraper will going to be there. So what's the solution? In Burj Khalifa, there is no shading device. There are open facade, glass facade.
The
So
kind of
how to, sir? Yes.
used is very expensive. That's what I'm saying. I'm not saying that do, you will not build. But again, as somebody was asking me at planning level, why do you need skyscrapers? Because you're concentrating population at one point.
One
Why are
point.
you concentrating population at one point?
Yes, sir.
Because you don't want to give economic employment equally distributed at all locations. You want only few centers to work. So there are many reasons. The thing is, I'm not against them, but then there is always a reason behind why some things are happening. Yes, we need skyscrapers. You're pumping in money, but you know how much a flat cost in Burj Khalifa? They are charging you for the glass they have used.
Yes. Still
So
more than 70% of the Burj Khalifa is unoccupied,
is
upper
yeah.
levels.
If you don't want to use shading device because of course you will have an additional load on the building, then you will go for that special glass. So every decision will incur another challenge. So design is looking at the total circle. I'm not saying no to what you do, but I'm just questioning that,
Okay, sir.
okay, you do that in Burj Khalifa, but why do you do it in WTP? That's not 800-meter high. Why do you do that in a residential tower, which is only G+5? So when we, you know, refer some building and make it somewhere else, do we refer it entirely? Are we making a skyscraper or are we just using glass? In last 10 years, I see the glass panel being used at G, ground story, ground plus one story, everywhere. It's just like a fancy material being used in a wrong way. And
Yes.
in my presentation, I'm already making a point that glass was used in 50s too, 60s too. The entire curtain wall was there too. In fact, my school had the concrete frame and glasses on Madhyamag, but it was used to draw the north light in. But we had sunshade devices on the south facade. So the whole point is how you use material. It's like what you do with it makes more sense. If you need skyscraper, yes, you will go with the logics of skyscraper. But again, if you're looking at sustainable development, I think if you read about sustainability, it talks about something that we can sustain. How many Burj Khalifa can we make every year? That's the question. Is it sustainable?
Thank you, sir.
Okay.
I got.
Thank you, sir. It was a very wonderful session by Professor Sharma, and hope our budding architects must have learned something from it, and they will take very important steps in their future for the sustainable development. And here, I, on the behalf of the whole Jagannath
There was
family and
another
the entire
there
team.
was there was another hand raised actually. I don't know if you want to
Okay,
take that.
who
Nahid,
was here?
Nahid Akhtar.
Himanshu Swami. Himanshu Swami. Nandan sir, can you unmute Himanshu Swami once?
Himanshu and
Himanshu
there.
Swami.
Okay, fine.
Himanshu
Otherwise,
Swami.
otherwise, I'm okay. I just saw the hand raised. So.
Yeah, I also saw one more hand. Nandan sir, once go for Himanshu Swami.
No, sir. Yeah. Please unmute. Vanshu?
Good afternoon, sir.
Himanshu.
Good
afternoon,
afternoon.
Himanshu. You can ask question from sir.
Sir, I was asking that the question that a plot is compact from three sides. So it was the question that I was asking for sunlight. तो सर सनलाइट मतलब अगर मतलब कोई प्लॉट है इंडिया में हम देखें तो प्लॉट मैक्सिमम प्लॉट ऐसे ही कटते हैं रेसिडेंशियल जो कॉम्पैक्ट होते हैं जो एकदम चिपके हुए होते हैं और इनकी डायमेंशंस बहुत कम होती है तो उन घरों में हम किस तरीके से सनलाइट अंदर ला सकते हैं मतलब फ्रंट साइड के अलावा बिकॉज फ्रंट साइड में मतलब पूरे टाइम नहीं होती सनलाइट तो उसके अलावा हम सनलाइट कैसे ला सकते हैं अंदर
तो हिमांशु वही मैंने आपको बताया पहली चीज कि अगर इंडिया की बात कर रहे हैं और अगर वो हिल्स नहीं है तो हम पहला एक तो टर्म मैं आपका ठीक कर रहा था कि हम डे लाइट की बात करेंगे डे लाइट और सनलाइट में फर्क होता है सनलाइट तो जो सोलर रेडिएशन है वो सीधी आ रही है दैट इज सनलाइट बट जो स्काई लाइट है जो सन तो एक डायरेक्शन में होता है पूरा स्काई इल्यूमिनेट होता है उसको हम डे लाइट कहते हैं वो ग्लेयर फ्री होती है वो हीट अपने साथ लेकर नहीं आती लेकिन जो सोलर रेडिएशन है वो अगर हम लाइटिंग के लिए यूज करते हैं तो अपने साथ हीट भी गेन करवाती है बिल्डिंग में राइट इफ यू अंडरस्टैंड द डिफरेंस बिटवीन डे लाइट एंड सनलाइट तो अगर इंडिया की हम बात करें तो अगर सनलाइट नहीं आ रही है अच्छी बात है लेकिन डे लाइट आनी चाहिए क्यों क्योंकि हमें डे लाइट अपने काम को करने के लिए चाहिए उसके लिए मैंने बोला कि अगर आपका प्लॉट छोटा है 3 साइड बाउंडेड बाय अदर डेवलपमेंट है तो अगर आपके पास कोई ऑप्शन नहीं है एक तो मैक्सिमाइज द डे लाइट फ्रॉम द फ्रंट जो कि आपका स्ट्रीट वाला फेस होगा जब हम एक फसाड में सनशेड लगा देते हैं सन वहां पे आता है सनलाइट आती है तो क्या होती है रेडिएशन ब्लॉक हो जाती है लेकिन जो स्काई उस शेडिंग डिवाइस के बीच में से दिखता है दैट परमिट्स द स्काई लाइट द डे लाइट इनसाइड तो हमें डे लाइट चाहिए सनलाइट नहीं चाहिए
सनलाइट
हॉट एरियाज में और दूसरा है मैंने बोला कि आप एक वर्टिकल शाफ्ट्स जो सेंटर में जहां नॉर्मल थंब रूल है 3 से 7 मीटर के बीच तक एक आपकी डे लाइट जो है अंदर पेनिट्रेट कर सकती है उसके बाद आपको एडिशनल सोर्स ऑफ लाइट चाहिए अब वो आर्टिफिशियल हो या फिर वर्टिकल शाफ्ट्स आप अगर एक्सपोज टू स्काई कर सके तो जो कि मैंने आपको बताया कि जयपुर में जो कोर्टयार्ड हाउसेस हैं वो बहुत अच्छे से ये काम करते हैं उनके 4 साइड्स आर बाउंडेड 3 साइड्स आर बाउंडेड और फ्रंट जो ओल्ड सिटीज में मैंने कई कुछ घर छोटे भी देखे उनकी फ्रंट जो है बस वहां से दे कैन हैव डे लाइट थ्रू जालीज and they have a courtyard which is almost acting as a shaft and it brings the skylight
मतलब जो सनलाइट है मैं सर सनलाइट का ही कह रहा था मतलब वो जो रेडिएशन होती है तो सर एक्चुअली घरों में देखें मतलब ये चीज मैंने बहुत से घर में एक्सपीरियंस करी जो नीचे वाला पार्ट होता है अगर सनलाइट नहीं आ रही तो सर वहां पे थोड़ी डैम्पनेस होती है उस वाले पूरे पार्ट में तो सर सनलाइट से मतलब वो थोड़ा जो एटमॉस्फेयर है उस जगह का वो थोड़ा सही हो पाता है डे लाइट मतलब रेडिएशन इज इम्पोर्टेंट फॉर दैट एटमॉस्फेयर वो डैम्पनेस नहीं जाती सर वो डैम्पनेस हमेशा रहती है उस जगह पे अब मुझे जैसे एलर्जी है उस चीज से, तो मुझे वो एक्सपीरियंस होता है कि अगर मैं ऐसी जगह जाता हूँ तो मुझे ठीक आना स्टार्ट हो जाती है। वो चीज सर किस तरीके से हम उस चीज को दूर कर सकते हैं?
देखो, एक तो पहला चीज ये है कि जो इफ यू रियली वांट सोलर रेडिएशंस, मतलब इट्स एक्चुअली वेरी गुड क्वेश्चन एंड वेरी इंटरेस्टिंग, मे बी वी आर एक्सटेंडिंग टाइम। पर पहली चीज कि मेरी डैम्पनेस बिल्डिंग में आ क्यों रही है, वी मस्ट अंडरस्टैंड दैट। तो उसको सुखाने के लिए मैं सोलर रेडिएशन को दीवार पे डाल रहा हूँ और मैं हीट गेन कर रहा हूँ। मतलब द प्रॉब्लम इज समथिंग एल्स, उसका शायद इलाज भी कोई और है, राइट? और
Yes.
उसका मैंने तरीका, क्योंकि हमें कुछ सोल्यूशन तो निकालना है, तो मैं
हाँ
सोलर रेडिएशन से उसको सुखाने जा रहा हूँ। होगा कुछ नहीं, डैम्पनेस फिर भी आएगी, बंद तो होती नहीं है।
सर, ऐसी
डिस्कलरेशन,
ऐसी
डिस्कलर
डैम्पनेस नहीं कि
listen to
मतलब।
me, listen to me. The discoloration of wall will also happen. Now, first thing is definitely there is something wrong in construction that needs to be fixed. Now, second thing, the daylight, if you read reports, is sufficient for the healthy well-being of the occupant and for de-infecting the space. Third thing, solar radiation can be welcomed when the angle of incidence is very low, like very, at the morning, at the evening. If you have your openings in such a way that only morning and evening is radiations which are at very low angle penetrates, you can do it. Now, for a compact plot, you don't have much choice. The only way you can draw the light is from the front facade and through a skylight well. Now, how deep is your skylight well? I mean, how many stories have you constructed? Will give you, allow you whether the sun rays at low altitudes can penetrate inside at the lower story if you really want to. I would avoid it in a hot country like India. But yes, during winters, yes, it would be a source of heat gain. Yes. That's my take on that.
थैंक यू सर।
Yeah. Thank you.
Must have learned so many things, so many technical things. And uh, also, I would like to tell my students three very important things जो कि सर ने आज हमारे साथ में डिस्कस की. The first one is that we must learn from their past, the informations which have been transferred to us from generations to generations regarding the nature, regarding the sun path and everything. हमें इसे फॉलो करना चाहिए. सेकंड थिंग, वी शुड नॉट रिलाई ऑन द सॉफ्टवेयर्स ओनली, जैसा कि सर ने हमें बताया कि यू मस्ट हैव योर ओन लॉजिक एंड अंडरस्टैंडिंग एंड देयर एप्लीकेशंस. और द थर्ड वेरी इंपॉर्टेंट थिंग जो सर ने बताई is the sun path diagrams are not those fancy smileys what people used to draw on their sheets. It has some relevant applications also. So I hope our students will understand this important discussions and things told by sir. And here I, on the behalf of Jagannath family and the entire technical team which helped us to organize such a fruitful interactive session with Professor Sarma here, I would like to offer my thanks to sir. And thanks to everyone, thanks to my students showing this much of response in this interactive session. I hope my students will do something good after this session in their practical applications. Thank you so much,
Excuse
sir.
me, sir.
Yes, sir.
One student has also a question.
Sure.
Nandan sir, please unmute Nahid.
Okay. Anandan sir, please unmute Nahid.
Yes. Yes, I saw his hand before that. Yeah.
Good afternoon,
Last
sir.
question.
Good afternoon.
Sir, I totally understand the concept of sun path, material, or orientation that we should keep in mind in designing any of our structure. But what about, sir, commercial buildings or office buildings or even a hospital building? Even hospital building, it is recommended in for the west facade or south facade because of the bacterias or for the decrease in bacterias, or if we talk about a commercial building, taking an example of WTP, so it is I think it is justified to use facades in the glass facade in west side because they are affording 24/7 air conditioning, and if I own a luxury or electronic showroom there, I can I afford 24/7 air conditioning there. So I don't think so that we should uh, we should keep in mind in for the orientation in all types of buildings, because if it is a residential, we should keep in mind these things. But if it is in a office building or an commercial building or a hospital building, I don't think it is neglected.
Okay.
What are your thoughts about it?
Yes, I'll actually the when I was making the presentation, I could not include all the buildings, and somehow the shopping centers of Chandigarh got missed. Now, I don't know how much you know about the city, but the each neighborhood or each sector have has its shopping center, again aligned in such a way that its longer side is north-south, and the piazza or the entrance or approach to the shops is from the northeastern side. So what happens is the shop timings are from 11 a.m. till 11 p.m. When before pandemic. So people normally shop in the late afternoon, and by that time, what happens is the built mass of the shopping street shades the street itself. So you can walk around, access the shops, and there, of course, right now it's a brick facade, or but if even if you glaze that orientation, there is no problem. As I said, I do not have problem with the glass, but where you put it creates challenges. And if you keep mitigating those challenges, it's fine. I mean, if you run air conditioning, it's fine. If you can afford it, but I think we should have a larger responsibility to the environment too, because everything that we pump in to keep the show running is damaging the environment somewhere.
It's damaging the
So even
environment.
if you
Yes.
can afford it, let's not damage the environment totally. So maybe we can have another session, but the shopping. So there are examples even in Jaipur. If you see, if you see the street which is connecting Badi Chowpar, Choti Chowpar, you would, if from even from your memory, you would see there is one side of the street which remains shaded during the afternoon and the other is exposed. And believe me, you'll agree with me that the side which remains shaded has most popular shops, including LMB, and the other side, very little shops that you remember or are frequented. It's like that. It's a natural response to the thing. Why do you think? I mean, to Nahid, why do you
Yes, sir.
think the GT square works more, has more sales than WTP?
Because
Yes,
of the yeah,
it has
sir. But
it has a very small piazza. It has I mean, other than the like the common man will say that these shops sell price products at a lesser price, but there is another thing to it. It has a smaller piazza which remains shaded at the time when the shopping activity is happening. Trust, you can go and verify it. You know where all the food courts are, those chota chaat walas and all. That's GT square that it forms. Because of its orientation, it remains shaded between 3 p.m. to evening, making the evening activity. So built form can influence even the shopping streets and consumer behavior. Acha, Sajal also has a question. Well, solar radiations, yes, they do. But where do you, if you read the healthcare literature, and you read the planning guidelines for hospital wards, uh, they want you to have daylight. In the colder climates, they want you to have sunlight. So I'm using both the terms. In the colder climates, they want the sunlight to come in. In the hot climates, they want daylight to come in with accessible areas outside where the patients can be walked around. What are the areas that need solar radiation to kill the bacteria? You cannot expose the entire hospital to solar radiation. That is something you have to understand. I showed you the plan of General Hospital and its orientation to you. I'm sure I was born there, by the way, just disclosing personal information. But what idea is that you're shading the things which are unnecessarily gaining heat. You can always expose your building to solar radiation whenever you want. But first, critically think what are the areas which are depending on solar radiation for disinfectation. You do not need solar radiation in OT, which is the most sterile zone. I have never seen an OT exposed to solar radiation. Can it be? No. You use another mechanism uh, for its making it sterile. Similarly, so you first tell me, or rather, find out what are these areas in the hospital which depend on solar radiation for disinfectant. But yes, your wards should have sunlight if your hospital is in cold climate, and south facade will help. And your ward should have daylight if it's in hot climate, and accessible areas to outdoors. This is what I understand of hospital design.
Yes, sir. I think it's time to end the session. I hope doubts from the students are clear. And sir will share the presentation with everyone. And
yes, I can share with Praveen sir.
And yes, and Praveen sir will
Okay,
send
sir.
you to all the students this important presentation. And thank you so much, sir, for enlightening us and helping our students to understand practical passive solar architecture. Thank you so much, sir.
Thank you so much, and I hope I have answered to my best capacity the queries.
Yes, sir.
And
course, sir.
queries are
Yes,
good. Having question is good. I think that's very important.
Yes, this makes the session very interactive.
And in the end, I would just say there is never one thought, one thinking. It's a collective effort, but basically at this point of time, our collective focus is to have a sustainable environment.
Yes, sir.
And long-lasting environment. Human beings have proved that they can do extremes.
Extremes.
Yes, but we cannot keep doing them again and again because
but
it's
it is
going
not needed unless and until it is necessary. We shouldn't go for it.
Yes, it's like a sugar high. We don't have to remain on a high all the time.
Remain on high. Yes, sir.
Okay, with that, I think, thank you so much.
Thank you so much, sir.
I'll take an exit.